we're talking about how to model a competitive situation using an extensive form, and that's kind of like this tree branch diagram right here. And extensive form diagrams are used when you have a sequential game. In other words, when you have a first mover and a second mover. Chess, for example, is a sequential game. You move in turns. And there are advantages and disadvantages of being a first mover and a second mover. The advantage of being a first mover is you get to initiate the action. You get to determine when the game starts, where it starts, things like that. The advantage of being the second mover is you have more information when you act than the first mover, because the first mover has already committed himself or herself to a course of action, and you could use that information when you plan your course of action. So there are pluses and minuses in this regard. But what happens when you have a game that is simultaneous move game? And in a classic example of a simultaneous move game is a rock, paper, scissors. When you play that game, both players choose their selection, rock, papers, or scissors, at the same time. That is a simultaneous move game, and the extensive form cannot be used for a simultaneous move game. So what can we do for a simultaneous move game? Well, we're going to use something called normal form. Normal form is just a illustration of a game that's moved at players move at the same time. So let's take a situation where we have a player 1 and a player 2. And each one of these players has 3 possible courses of action. And we'll set them up in a matrix. So the strategy for player 1 in red is strategy little a, little b, and little c. Strategies for player 2 in blue, big A, big C, big B, big C. And what we're going to populate in these boxes in each cell are payoffs. So in other words, if player 1 chooses strategy little a and player 2 chooses strategy big A, capital A, then player 1 is going to get 12 and player 2 is going to get 11. Now let's call this a profit. So player 2 is going to get 12, player 1 is going to get $11 worth of profit. And we can see that if player 1 continues with his strategy of little a, and player 2 continues with her strategy of big B, you could see the payoffs here. 11 for player 1, 12 for player 2, and so on. So we could populate this whole matrix like this. Now let me give you some advice on how to read a normal form matrix. I'll give you a 3-step approach. Now these 3 steps may seem simple, but I guarantee you it will help some of you, because you've got to read this matrix from player's 1 perspective and player 2's perspective. And it's been my experience that some students do a very good job at reading a matrix like this using this. But they don't do a very good job in reading the matrix from another perspective, let's say from player 2's perspective. So step 1, clearly identify who you are. You'll be amazed at some students will try to read a matrix like this from both players' perspective at the same time, and they get confused. So step 1, choose who you are. Okay, let's say we're player 1. Step number 2, choose a strategy for your rival. So as player 1, I'm going to assume that, let's say player 2 chooses capital A strategy. Then finally, the 3rd step, choose your best response given what your rival is doing. So if player 2 chooses big A, I'm going to confine my vision just to these 3 possible outcomes, because if I choose little a, 12, big B, little b, 11, little c, 10, and they're all in this column because I'm assuming player 2 chooses big A. Now, if you're player 1, what should you do given player 2 choosing little a? Big A. Should you do little a, little b, little c? Now, some of you are saying choose little a. Why? Because you get the bigger payoff. But that's assuming you're a profit maximizer. What if player 1 chooses little b? Player 1 could be looking at basically hurting his rival the most. So you could see player B has the lowest payoff for player 2. And if that is your goal, is player 1 to punish your rival, that could be a viable option too. So it is clear that before you choose your strategy, you have to have a clear understanding of what your goal is. In this case, let's set our goal as profit maximization. So if player 2 chooses big A, player 1 is going to choose little a. Now, what if player 2 chooses big B? What should player 1 do? Well, let me see, hold on. Okay, if player 2 chooses big B, what should player 1 do? Well, again, strategy little a is the profit maximizing strategy. So then it's A again. Now, what if player 2 chooses big C? Again, player 1 should choose little a because that is the largest payoff of all three. So did you notice how no matter what player 2 does, big A, big C, big B, big C, player 1's response, little a, is always the same. So no matter what his rival does, player 2, player 1 will always choose the same strategy. We call this a dominant strategy. A dominant strategy is a strategy in which you do not care what your rival does because it's always in your best interest to do the same thing. In this case, little a. Now, the question is, what about player 2? Does player 2 have a dominant strategy? Well, let's see. Well, let's go back. Let's go back to a clear board here. Let's apply my three-step approach. Step 1, choose who you are. We're player 2. Step number 2, choose a strategy for your rival. Well, let's say player 1 chooses little a. As player 2, what should you do? Big A, big B, big C. Well, you're going to confine your vision just to this top row because this is the row that has consistent player 1 strategy, and you're going to say, should I do big A, big C, big B, big C? And of course, big C is your option because that gives you the biggest payoff. What if player 1 chooses little b? What should you do? A, B, or C? Again, you should do C. So maybe player 2 has a dominant strategy. Well, let's see if player 1 chooses little c. Should you do A, B, or C? Well, in this case, your best option is A. So player 2 does not have a dominant strategy because player 2's best strategy depends upon what player 1 does. If player 1 does A or B, then player 2 will do C. But if player 1 does C, player 2 will do A. So player 2 clearly does not have a dominant strategy. But even though player 2 does not have a dominant strategy, it is clear what player 2 should do. Player 2 should choose little a. Because, player 2 should choose big C. Because player 2 knows player 1 has a dominant strategy. So player 2 is not going to consider any of these strategies because these strategies in these bottom two rows have to do with player 1 choosing B or C. And player 1 will choose A because player 1 has a dominant strategy. So if player 2 confines his or her outlook to these three possible outcomes, they'll choose big C because big C has the largest payoff. So even though a player may not have a dominant strategy, their course of action still may be clear. Now, what we're going to talk in the next video is we're going to be talking about